Let's welcome Paolo for the next talk about awesome GenAI. And Purvi, sorry. I forgot how to read.
Yeah, perfect. Do you want to stay?
Yeah. And where's the pointer?
Oh.
Okay. I guess I'll stand here.
Testing.
Hello. Hello. So let's get started. Generative AI is one of the biggest disruptions software industry has seen. Watching it answer questions incredibly has also raised a lot of questions in our minds, making us skeptical to use it. We doubt of our job's existence, and we fear of getting dumber. What if we tell you that GenAI is not your enemy, but your ally? Hi, my name is Purvi Sharma, and I'm a software engineer in Booking's App Developer Experience team. And I'll be sharing the stage with our team's engineering manager, Paulo Pinheiro. Welcome to App Conference. Let's get started. Generative AI is just one puzzle in a very big family of AI field, but it's certainly the one that's got everyone's eye. One of the biggest challenges in this domain has been to make machines understand human language. And human language is tricky. Allow me to demonstrate. When I'm texting my friend, "Hey Jan, let's meet at the bank." Where exactly am I asking her to meet? What does this word bank mean here? Is it the bank where I deposit my money, like ABN AMRO? Or is it along the riverbank of Amstel? And to some of us, it can also mean our beloved old booking office, the bank. You see the problem? Knowing just the literal dictionary meaning of the words wasn't enough. Machines needed to understand what the words mean literally, as well as what they mean in the context. But once this challenge was overcome, the real magic began. In November 22, ChatGPT was dropped. Boom. And the internet went crazy. In just 5 days, 1 million people were using it. And in just 2 months, hundreds of millions of people were using it. That is the fastest adoption anyone has ever seen. And this next slide here is just a LLM family on steroids. A flood of faster, better, and smarter LLMs haven't yet stopped coming our way since then. At this point, I would like to uncover how LLM actually work. I believe that is necessary to relate more to some of the points that I'll be raising. The first fact to know about LLM is that they are like prediction machines. You give it an input, the prompt, and based on that, it tries to predict the next word that will follow it. Let's take an example. So when I query with the LLM, what color is the sun? Internally, it breaks it down into small chunks known as tokens, which is then converted into vector representation. And this gets fed to the neural network part of the LLM. This is then processed, and you get a resultant vector, which is matched against a list of words having very similar vector representation. And the top one, the most likely of that, becomes the answer, your output, which is white in this case. The second fact to know about LLMs is that they are autoregressive, which is just a fancy way of saying whatever word it spits out is fed right back into it to do the next prediction. The slide here shows how the sentence, "I love llamas," is translated into Dutch. And as you can see, both the input tokens and the output tokens become the context length and also known as context window for the LLM. Okay, now that we know that, let's see where it shines. I'll admit, playing with AI has been one of my favorite pastimes, and it's amazing at generating images, writing stories, and the list is very long. But the real magic lies in how it is transforming our day to day engineering work. This is how a typical software development lifecycle looks like. Quite familiar, right? Notice the stages haven't changed at all, but AI has seamlessly integrated itself into each of these phases. You're drafting requirements, AI will help you summarize. Testing, it will write unit tests for you, which you weren't going to write anyway. But the biggest shift has been in the development phase itself. Let's zoom a little bit into it. Not so long ago, this is how we used to develop. You write code, you search online, or you ask a colleague, you fix the error, you debug, and you return. But isn't this illegal now? This is how we code now. Now we do vibe coding with agentic IDEs like Windsurf and Cody. And with these IDEs, now the development phase looks more like this. You write a prompt, you review the output, you adjust, and you repeat. Quite easy, right? Now, how do these agentic AIs solve these problems? The magic here is agentic IDEs, they may leverage LLM's reasoning capabilities. So they use these LLMs to first come up with a list of action points and decide in what order to execute it. So when you submit a query to these IDs, the first thing they do is they do a semantic search. They form a logical reasoning, which forms the basis of creating an action plan. And with a human in the loop, which is us, the humans, the developers, they either execute that action plan or they adjust and repeat until you get the final output, which is code in this case. So what problems that these IDEs took away? There are two major ones. The time spent writing the boilerplate code and the time spent exploring the repo to find where to get started. And the impact? Well, the number one would be very fast prototyping. A good first draft of any problem is just one prompt away. The second one is in the onboarding. You do not need to know in depth any of the language, framework, or platform that you're working on. They just give you a head start and you are ready to get started with it. The next one is debugging. These coding assistants are literally like assistants, which can help you debug whatever errors that you're facing with their amazing searching capabilities. And they make the debugging really easy and faster. And the last one, they make it really easy to try out different models because they are just there in one tab. And you can compare the results of different LLMs and choose the one that fits your purpose. How wonderful, right? These LLMs have made us feel quite powerful and have given us a lot of satisfaction. And fueled by this, a lot of people also went to the internet to make their own bold predictions. So some people said, this marks the end of Google search. And some even said, all the entry to mid-level engineers will be replaced by AI by the end of 2025. Not so fast, Mark. What happens when this hype meets reality? ChatGPT 5 was released this month, and we all know how much it was backlashed by people worldwide. They had to reinstate the older version, ChatGPT 4.0, in the same month. A lot of people now believe that maybe LLMs have already peaked. Here's another one. This is a report from MIT that tells you that 95% of the new AI pilots are failing. They aren't making any real money or revenue. Only 5% success rate. 5% of them are adding any real value to the world. Where did we go wrong? It's so amazing. Let's look at some harsh truths. So if you look at the marketing advertisements of any of these AI companies, they have one thing in common. All of them promise you that your imagination is your only limit. Some even say your idea to your reality is just one click away. But no one, not a single one of them, talk about the real limitation here, which is context length. Yes, remember how I told you LLMs are autoregressive? Well, both the input and the output form the context length, and context length for each LLM is fixed. So a 100-turn conversation can quickly cost you $100. And imagine the compounding effect of this when you multiply by number of users using your application. This is the biggest reason why all of these AI pilots are not surviving, because it's way too costly to scale them. Here's another big one, the old nemesis, legacy. It's really tricky to integrate AI with legacy systems. They are everywhere lingering around you. And they are the reason you cannot build anything beautiful and elegant. No matter how trivial your new feature is, it has to be backward compatible to the first stupid thing that you ever built. Imagine having to feed all those logics and conditions to a very big prompt and send it to the AI. This is where the magic begins to fade. Next one. AI struggles and doesn't work that seamlessly when it works to structured data such as JSON. And the reason is very simple. These texts can be full of abbreviations and shortened keys. For example, in this snapshot, the topmost key here in the object is CCC, which means cost center code. How the hell is the LLM supposed to know that it means that? You either need to pre-process your data or feed all of such information to your context, right? So no, my idea to reality isn't just one click away. There's a hell lot of work that I need to do before LLM can actually work with these things. The next one is accuracy. And this is a good one. LLMs can sound very confident, but they can be confidently wrong. This is called hallucination. Why? Because they are trained on internet data, which is full of false information and biased facts, causing them to hallucinate. Here is a real-world example of hallucination, where Gemini was telling people how eating one rock every day is really good for your gut. Thank you, Gemini. We'll do that. But on a serious note, most of the LLMs are capping at 80 to 95% when it comes to accuracy. They are doing really well when they are asked questions on topics which have abundance of data available, but they fail poorly and are very disappointing when it comes to niche and esoteric topics. Something to keep in mind. Now, some people will say, so what if aren't that accurate? Just feed all the conditions they want in the context, and there you go. No, that is not how it works, because long prompt doesn't mean better results. Just like humans, LLM lose focus when the context is very long. In fact, there is no guarantee that they will understand and follow every instruction that you give to them. Most often it is observed that the context in the middle is forgotten. That's why it is recommended to keep the most important thing either in the beginning of the prompt, known as the primacy effect, or in the end, known as the recency effect. This one is my favorite. Now, we all know how fast AI can generate code. It's quite marvelous, but the code written by AI is very verbose, beautiful on the surface with 100% code coverage. But if we just allow them to be merged right away, we are paving a way for destructions, because LLMs cannot think what they don't know, which makes it all the more necessary to scrutinize and review the code and think of what it has missed out on. Your application will soon become full of bugs and performance leakage here and there in different tiers of your app. What may seem as a productivity boost in the beginning may quickly transform into maintenance havoc, and nobody wants that. And this brings us to the last one in this category, which is trial and error. It takes a lot of experimentation and trial and tweaking here and there to work with LLMs. It's almost like reverse engineering the model. You poke at it until it gives you what you want it to do based on what it has learned in the training. And the second thing to add on here is not every LLM is fit for all the use cases out there. It depends on the underlying technology and what kind of data it was trained on. So you pick the wrong LLM and you're wasting your time, money, and effort. So at this point, I would like to summarize everything that I've said. Yes, LLMs are very powerful and intelligent machines. There's no doubt in that. But they aren't as autonomous as they are painted to be. They need human hand-holding from time to time and places to places. So the question to ask here is not whether we can use AI in production. The real question is, how do we build systems that actually work efficiently in production? And the answer to that is there are 4 ingredients to a successful generative AI production application. Number 1 is bounded context. They just do one thing, but they do it really, really well. They have very clear input and output definitions. Number 2 is guardrails. These are just proactive measures taken to avoid anything bad from happening. For example, filtering your input to remove any user PII to prevent leakage. The third one here is feedback loop, and that is to ensure the LLM knows what is working and what is not. This includes things like prompt tweaking, adding human reviews, and validations for the output. And lastly, a flow-based architecture to tie everything we discussed from point 1 to 3 together. It basically orchestrates all the tools, actions, feedbacks, and guardrails to solve the bigger problem at hand. And yes, we have a successful in-house application that uses generative AI. We call it AutoGenKit. And Paulo here will be giving you a deep dive today. Over to you.
All right, so we see that LLMs and generative AI is a very powerful tool, and we would like to explore it. So here's what we did. This is the name of the tool that we use, AutoGenKit. And first, I would like to share the goal of our team, App Developer Experience, which is to ease the development of our mobile apps through the state-of-the-art tooling and processes. So what we decided to do was to look what are the major pain points for the developer productivity and developer experience, and decide which ones will be the best to tackle using GenAI as our exploratory pet project. So there's a tool that Booking uses called DX. It's kind of a survey tool that every quarter, if I'm not mistaken, we share with the developers, and they come up and show the pain points that we have in the developer experience. And this was the result for 31st of March. As you can see by the votes, the number 1 was documentation, number 2, production debugging, test coverage, and so on. So looking at this list, we tried to figure out which ones would be a good candidate for us to tackle using GenAI. And we decided to go with those 2 first. The initial reason is with the LLMs we're going to use, we're not going to initially put code in production. So we are changing documentation, we are changing tests, but we are on a safe space to explore because right now we are not generating anything that would go into production. And it also number 1 pain point, number 4 pain points. So it sounds like good candidates. What are the challenges on those 2 aspects of development? First one is the human factor. Lack of time and motivation is a concern when it comes to documentation and unit tests. Probably some of you already had like tight deadlines and you decide to sacrifice something to make the deadlines, and this something is usually documentation or unit tests. Architectural changes. Sometimes you have major architecture changes. Your documentation is already there and you need to redo it, right? So it's also something that you have to keep maintaining it. Same for unit tests. You have unit tests, the more unit tests you have, the harder it is to maintain them, because if you do a structural change, you need to rewrite the tests to comply with the new API, for example. And finally, organizational issues. Maybe your organization does not have a standard practice or a guideline on how to treat unit tests or documentation, and makes it hard to have a uniform approach in the code base. Some teams do one way, some other teams do other. Some teams have criteria that is different than the others. So those are the challenges. And we are trying to figure out if there's a way for us to bridge this gap and make it a little bit more simpler for the developers. So July last year, we started building this tool called AutoGenKit. And what is it? It aims to be an AI-powered toolkit that enables developers to generate and transform code at scale with minimal effort. So the key words here is scale and minimal effort. The idea is to perform bulk changes, code transformation, and make it easy for the developers. The tool itself can be seen as 3 pillars. Those are the foundation of the tool. The first one is platform wrapping. The second one is the AI flow API. And the third one is end-user tool. So I'll go over each of them so you can understand a little bit better. For the platform wrappers, basically what we are doing is we are creating a Python API that would ease the access of the build tools that we use at Booking. So we use Maven, we use Gradle, we use the Xcode, and we have within AutoGenKit an easy way for us to access those tools and compile, test, do most of the work in a scripted way. So for example, this is a way you can use the AutoGenKit to compile and test Android file. So see, in one line you compile the file, my test, and if it succeeds, you can run the test. This is a part of the foundation for the workflows that we built in the end user tooling. But if you are building your own script, your own automation, you can also take advantage of the wrapping that we have already. The second part of the tool is the workflow API. Basically, it's an easy way for us and for whoever wants to build custom flows to create a series of steps that you can add context and ask LLM to intervene along those steps. Here's an example. This is a real example. This is how our documentation generation tool creates a flow. As you can see, it's a quite simple flow. We have 5 steps, if I'm counting correctly. And basically, we generate the prompt. We request the LLM the output of the documentation. We generate the candidate, which is basically applying the documentation to a source file. We validate, and we finally calculate the coverage just to see if there was indeed an increment in the documentation coverage. So this is the real flow we use. Of course, it's not fully here, but it's quite simple. It's like 150 lines of code. This is another example of workflow. This is for the unit test. It is a bit bigger, as you can see, so that's why I didn't put the full code here. So instead, I went to a diagram. And basically, what it does is we calculate the coverage of the project. And based on that, we triage the classes that still needs to be improved in terms of testing. And then generate a database. Based on this database, we send it to the LLM and ask it to generate unit tests based on the specifications we send on the prompt. And the result of it goes through a series of validations. As you can see, it needs to build, it needs to pass the static checks, and it needs to improve the coverage. Otherwise, we discard the test, or we send it back to the LLM saying there is an error. So this is the loop that we have to generate the unit tests. And as Purvi mentioned, the 4 steps that we need for a successful GenAI product is here. So the bounded context, we are very explicit in what we want to test, and we filter out as much as possible for the context. We have the guardrails, where when we call the LLM, we make sure that the output merges correctly with the code. And we have the feedback loop, where we use standard tooling, like lint checkers, the compiler, the day-to-day stuff to check if there's errors. If there's anything, we send it back and say, hey, can you please fix this is the following error for the following tool, generate a new candidate. So this is the whole flow for unit tests. And of course, the tool allows you to create custom flows. All right, the third pillar is the end user tool. Basically, this is the part where people actually use AutoGen Kit at Booking for now, which is basically the way you can document or generate tests for your project. So as you can see, we create a command line tool called Autodoc, which basically you pass the folder of your project and it generates documentation for you. Yeah, that's it. Documentation management. I can show you some of the features for this particular tool. Fixed commit. This is a pretty interesting one that I guess probably at Booking only I am using, which is basically when you commit the code, if there is a function or method that is not documented, it automatically generates the document on the commit itself. So I don't have to worry about it. I just write the code commit and it will fix the commit for me, basically. Second part is to manually generate the documentation. So you pass a folder, say, hey, this folder has a lot of Kotlin files. Can you please document it for me? It will do it. For now, we support Kotlin, Swift, TypeScript, JavaScript, Python. I guess that's it. And finally, the last one is very interesting because this is the update. And that ties directly to one of the pain points I mentioned before about the updating the documentation, which can be quite expensive if you do major changes on the architecture. You need to go and rewrite stuff. So basically what this do is every documentation generated by us, it updates if it needs to. Like it look back at the code again and see if there's a mismatch between the documentation and the code. And if it sees a mismatch, it just updates. However, it only updates documentation generated by us. It doesn't update manual documentation. Aside this, we have 2 other tools, which is autotest, basically generate the unit test, and auto commit messages. We generate commit messages. But for the sake of time, I was just showing Autodoc, which is very interesting. So I mentioned the end user tool, I mentioned the foundations, but you saw before that we wanted to do minimal effort for the developers. So what does that look like? We have an engineering portal where we put several apps inside. One of the apps is called App Maturity, which basically is a series of metrics that we have apps that tells the quality of the code base. So one of the metrics is documentation coverage, and you can see it for your team. So in this example, you see several modules. Each of those modules are owned by different teams. And we wanted to help people to document to increase the documentation coverage of their areas. So what we did, we created a small wand button that you basically click on it, ask if you want to document set a fixed number of files or the whole module. Because if you document the whole module, you might have 100 files documented, and it's going to be hard to review. So you can limit it. And that's it. Once you click on it, you're going to receive a merge request in like 10 minutes. That's the minimal effort approach. If you don't want to go minimal effort, you want to have more flexibility, you can just go to our web UI version, which gives you more options. You can select for what type of LLM you want to use. You can select number of threads, number of tries in case of the unit test. Some include exclude patterns for if you want some files to be excluded. And I guess the most interesting thing here is now we have an override prompt that you can see the prompts that we are using, and they can allow you to do changes if you want. It's a very powerful tool, but it's also scary to use because you might affect the output that will be not tested by us as much, but it's there if you want to try. If you try and get a better success rate, talk to us because we can merge back the improvements on prompts that we have. This is the final example. Just as I said, like it fixed my commit messages. So this is a commit I did in the project. Autodoc added documentation for me, and the auto commit message generated the commit message for me. So that's the kind of approach that we are going for. Example of documentation. You see at the end there is a line say documentation generated by AutoGenKit. So that's how we know that the documentation is done by us and not manual. So this is a candidate for update in the future, if we want. You can see that documentation can be very useful. So this is a real code. And we have two fields called rel fname and fname. If you don't have documentation, it might be hard for you to understand what it is. But you can see the LLM understand it pretty well what it is. So the relative path, the first one, and the second one is the absolute path of the file. So there is value on the documentation that is generated. And this is just a sample of the commit message that was generated automatically. I don't write this way. So I write one line, sometimes just 2 words. So I suck at writing commit messages. This is definitely better than what I do. Okay, some tech deep dive. As I mentioned before, like we wanted to make sure that we have a tool that is well tailored for scaling and for minimal effort. And based on our experience, we realized that a pure LLM approach might not be ideal in terms of reliability. So we try to come up with alternatives to improve the accuracy on how reliable the tool is. So one of the things we tried out was to take pieces of the workflow that we see that is already a problem solved using classic algorithms, and try to take it out the jobs from the LLM and try to use LLM only on the things that are actually really hard for classical algorithms. So what kind of techniques we use, we're going to explore here very quickly. But before, the architecture of the service. Basically, we need to run compile tests in a kind of intensive. You can run on your local machine, but if you go for the engineering portal or the web UI, we use this approach, which basically have the front end sending to the control plane, which create the jobs on CI. Those jobs on CI will run the workflows. So it runs the documentation workflow, it runs the unit test workflow. If you have a new workflow that you created, it will run there as well. The reason we come up with this approach is because it's easy for us, because we don't need to worry about queuing, we don't need to worry about resource management. The CI already provides all these facilities for us. And also it's easy for us to dispatch merge requests to all other projects. So basically, if you have something on the Node.js project, you can run this job here, and it will send a merge request to the Node.js. The other reason is because we have a fleet of Mac machines. So if you're running for iOS, you need access to Mac. And as far as I know, on our cloud, we don't have access to Mac machines. So CI we do. Okay, there was a point also about using agents that we discussed internally among the team. So why we decided to go for workflows and not agents. First of all, is we start early. So you see, MCP was first published in November, so it's quite new. And we start the project in July. So at the time, agents already exist, some frameworks or was already existing, but it was very early stage, and we saw that we having more control through a workflow would work better for us than giving more control to the LLM. We might experiment in the future with agents as well, but so far the results, we see that simple workflows are very good. First version of the documentation flow we had, it was quite simple. We sent the source code. We sent the prompt, say, hey, document the public entities of this, this source code, which is basically what we care on the documentation coverage for our metrics. We send it to the LLM, and the LLMs outputted the whole file with the documentation in it. There were problems with it. So due to the hallucinations, the output has documentation, but has other stuff that we don't know why it was generated. It generates code for something that we are not asking for. And also it was documenting functions that were private functions, and that's what not we wanted, because the LLM kind of understands what we are asking, but sometimes it struggles with some specifics of the language. If a language is by default private or by default public, it was having a hard time to figure out what was the right entities to document. So we saw success rate was okay, like 30–40% of the code, the data generated was successful. But can we improve this? Yes, we decided to go through a more classic algorithm approach. Good old programming. So what we changed was we first parse the source code using a parser tool called tree-seeder. It generates an abstract syntax tree. And we use this tree to define which entities is going to be documented. So on the prompt, instead of saying, hey, document all the public entities, I say, hey, document entity A, entity B, entity C. Make it very specific. We also say, we only want the documentation. We don't want the whole file back, to make it simple for the LLM to output, to have less chances of hallucination and so on. And then we manually add it back. Because we have the ASC, we can manually add it back the documentation without causing any major issues. So, okay, how the parsing works. Basically, there's a very interesting tool called tree-seeder, which most of the IDEs are using. It's a tool from GitHub, and it supports basically any language you can think of. I think there's more over 100 languages that support, and the major ones also. So the way it works is basically what I have. I receive the source code. I figure out like what is the language I'm working on based on the extension. If it's a KT file, it's Kotlin. If it's a .swift, it's a Swift. I parse and I return the tree back. And that's what it looks like. You see, there's a module for this function, hello world. I get this ASC back, and that's what I can extract the entities. There's what I can figure out what is public, what is private, and I can send specifics for the LLM. Because every language has a slightly different structure, you need to create queries for each language. So That's what we did. So we have on the project a query for all the languages to query the right entities. So as you can see, this is the same Python one. And you see the yellow words. That's where we define what entity is based on the AST structure. So the first one, every time you see this expression being matched in the AST, it's a constant. The second one is a class. The third one is a function. And the last one is a reference call. That's we don't use for documentation, but we're going to use later to feed the LLM on different other workflows that needs more information. And finally, that's how we separate and returns the entities. We basically just do the query and we check the enable definitions. So as I mentioned, we were only looking for public entities to document and not all types of entities. So for example, on Android, we don't want to document data classes. So it's something arbitrary, but we need to have some flexibility in what we want to document or not. And based on these definitions, you can filter out what you want to document or not. So in this case, I just want to document classes and functions. This function will return only the things that you care about. Cool. That's how we parse. Now we want to show you how to inject in the prompt. This is going to be a very simple one. We are using Ginger. I guess if you have Python developers here, you know already how it works. But basically, it's a templating system, and we are pairing it together with YML just for the sake of inheriting different blocks of text. So as you can see here, this is how we generate the documentation prompt. You see we are injecting the language and the code in the prompt itself. And we loop through the entities and tell like which entities we want to document. So every time we send a prompt, the prompt is slightly different because we are injecting this information directly using this template system. And now, of course, if you see at the end, this is a very critical part, is how we expect the LLM to output the code. This is a actually hard problem because LLMs are not very good at outputting structured code. So you need to be creative in the way that you ask it. Some models follow the instructions really well. Some others are more difficult. So you need to like do some trial and error to figure out. In the tool, we have this approach where we separate the documentation by this block of code. But we also have the option to use diffs as output or the full file. So depending on the flow, different outputs structure might make sense to use one or the other. This is just an example of the judge LLM. So on the unit test tab, we also have a judge that look at the unit test and say, hey, this test is crap or not. Actually, this increased a lot our success rate because it filtered out a lot of useless tests. And basically what we are doing here is just like assigning it as a role. We are giving the goals, which is filter out tests that are not useful. And then basically we inject the information, all the information here below. Finally, this is something that we are playing on right now, which is to reduce the context size using a tool called RippleMap. Basically, one of the things that we are trying to create now is a flow where we look at the whole code base and we generate high-level documentation. So it's a bit more complicated to generate documentation for functions and methods because the context window can be huge. I think our Android code has like 8 million lines of code, if I'm not mistaken, but many millions of lines of code. You cannot simply send it that and ask for it to document, right? So you need to find creative ways to do it. This is a tool created by the Aider tool. It's a very famous open source, and it's a very creative way of doing it, which basically takes the source code, removes the code, and leaves just the public API. So as you can see here, it has the class name, it has the method parameters, but it doesn't have any code at all. So with that, you can drastically change the size of your context window, and you can send full modules for it to get an overview of it and generate a high-level documentation. So we are playing with this right now, and it seems like it's going to be very, very useful. Okay. Yeah. As I said, this is a library made from Aider and open source. Just go there and take a look if you want, or use your code base. Some results. This is unit test. So we have the unit test flow live for more or less 7 months. And we see some good numbers. Before we started, we had the unit test at around 27%, the code coverage, and we moved to 34% in the 7 months of use. Of course, there's also manual unit tests being generated, but also more code being generated. So we cannot attribute this number directly to AutoGenKit, but we do know that we have a heavy influence. Especially if you see a bump there that I'm showing, that I'm highlighting. This is when we launched it and sent to the community. So there was a bump, and then they start to increase steadily. Now for documentation. So it's a little bit younger. So it has more or less 6 months right now. And before we started, we had 10% of our code documented. And when I say documented, I mean public API, not private functions, for example. And now we are at 30, so it's amazing numbers considering the size of our code base. Out of those, 42% of the documentation of the code base is already managed by us. And it's more or less like 20 lines of code generated, lines of documentation generated. You can see the curve, like it's more steep on the documentation rather than unit tests. We believe the reason is for documentation, we have the minimalistic approach where you can just go to the module and click on the button to generate documentation. We don't have that yet for the unit tests on the engineering portal, so it's much easier to just go there and click. For the unit test, you either have to use the web UI or using the command line. So we're gonna add it soon to the engineering portal. We hope it start go up the same way as going for the documentation. Yeah, so it took 14 years for us to get 10% documentation coverage, and we moved to 30% in 6 months. So I think there is value on using generative AI if you go in a very disciplined approach. And okay, I showed at the beginning that we had #1 problem documentation and #4 test coverage. So for April this year, we kind of improved it. So it's like #5, #6. Of course, that might also mean that everything else got worse. So there's this option as well. But keep in mind that this is filtered out by platform. So this is just for mobile, Android and iOS. And if you go to the whole company, back to all the platforms, it's still #1 documentation. So we do effectively have an effect. Something changed on mobile. It might be us, it might be something else, but I think we do have also an impact on there. And another thing to notice is also 6th of April, so there were like 3 months of running the tool. So we do expect to see changes on these numbers also. Cost. So we are sending a lot of data to LLM, how much it costs. This number is not taken from us, it's taken from the gateway API that we use to connect to the LLM. And they told us that in the last 30 days, we spent 7 cents on LLMs. So it's quite cheap. The reason for this is that we are very specific in what we send and the output. So, for example, remember that in documentation, the first version we are sending back the whole file. So it's a lot of tokens. But now we are not doing this anymore. We are just getting the documentation back, which is just a tiny fraction of output tokens. So processing the data before sending to the LLM and be very specific in what you want back can save a lot of money, right? And I guess maybe some of you have used Cloud Code or those agentic, and you know that you can get out of credits very quickly, right? So this mixed approaches can be very efficient. Some insights: simple flow, effective, can bring high value. Agentic is cool, and probably it might work as well as this, but we cannot discard simple things as well. And traditional programming, there's still a value on it, and you can see that it can make a big impact, especially when you join together with generative AI and let the AI work solely on specific tasks, giving high quality context and expecting specific output. It shines on that setup. Yeah, controlling the context window, you control your costs. It's going to be very cheap if you send few things and ask back few things. Different models varies wildly. So you have some models that are very good at following the expected output. Some models just break it, and it's very hard to recover from it. You need to create some techniques to clean up the data and get something meaningful out of it. And just like regular programming, is just trial and error. You create a flow, you keep testing until it reaches the level that you believe it brings value. So we have some next steps. We want to add more platforms. We want to refine the techniques with a few shots, like ask for test generation, but also send some tests that we believe is high quality so it can mimic it. Introduce styles of documentation. We want like a minimal style or Apple-like style or Google-like style. So people can select the persona of the documentation that will make them happy. And new flows. So generate UI tests. Test optimization is a big problem we have here at Booking on CI. Our tests are very slow. Some of them are. And what we can do is we can keep the loop, workflow in the loop to look at slow tests and ask it to optimize it. Fix lit issues before we send. And any ideas like John's migrating marking, it could be a good candidate to use it here as well. If you're interested in working on a generative AI and you have a flow in mind to automate part of your work that would be working on larger scale, just talk to us and we would love to work together. And I guess that's it. Thank you. I guess it's question time, right?
I need my microphone to give to the question givers.
Thank you for the talk, and the tool already saved me some time. There was a great example about absolute path and relative path of a file, and that made me thinking, if I would go and write documentation for it, I would also take an effort to rename those parameters to make it more intuitive, and people won't even have to look at documentation. Have you thought about maybe providing back some suggestions, what could be improved, not just providing documentation? And I can also see some use for that for tests, like if tests couldn't be generated, there could be some suggestions on how code could be improved to make it more testable.
This is definitely a good suggestion. Like we like to keep the flows separate. So we have this flow for documentation, and because we generate a documentation like this, we get insights that there are other opportunities, right? So we could have a flow that analyzes the source code and provide code smells based on what the LLM analyzes, right? So that should be extremely easy to achieve, actually. Because you don't have to go through the compilation step, you don't have to go through all those validation steps that are more expensive, and you can get a flow that would bring you this type of value very easily. Yes, it's a good idea.
Cool.
Hi, thanks again for the talk. I think you touched point on it, but I want to know more. Do you benchmark LLMs as well? And like, do you have highly recommended ones? How do you see and compare the results generated by each one of them? And how do you keep up with everyone popping up every day?
It's a lots of experimentation when it comes to trying the LLMs. So what we have seen is Claude is really good when it comes to the generation. Also, ChatGPT 4 is also really good there. So yeah, we do not recommend a lot out there because we are also testing right now. And these two are the ones that we recommend for now for these two use cases.
When we generate unit tests, for example, we have a code coverage percentage before and after. So at a given commit, you can run it with different modules, and you're going to see the coverage at the end result, the number of generated tests. So you can basically benchmark what models are more useful or not. So if you have a fixed commit, you can run this tool using different models in parallel, and you're going to get different results. And those results will tell which ones is more useful. One thing we noticed is Gemini is very bad at following structured output. So one of the problems we faced. So we were asking for documentation. It was bringing back documentation plus some code that we don't understand why. Yeah.
Hi. Question: how far you from like including it to actual workflow? Like not as separate tool, but like okay, I want to commit something, and it immediately put commit message there.
It's there already, right? So for documentation and commit message, you can just add it to the Git hook, and that's what I'm doing in my daily work. And it will automatically document for you. It will automatically generate a commit message for you. So this part is already available. Not for testing, because testing it's intensive. It needs to compile, it needs to do it. But for documentation and commit message is already there. I can follow up with you and help you set up.
Okay, great. And follow-up question: how do you benchmark like quality of outputs? Like for test, you have like test coverage and stuff like that. But how do you verify that documentation makes sense and not some random stuff?
Benchmark quality is a hard problem per se, because what we noticed is the documentation felt great for some people. From other people, they felt it was too much information. And for other people, they felt it's too little information. So we got a variety of feedback based on that. But the thing that we look into is the amount of accepted merge requests. So with that, we have an idea of how much the developers are satisfied with the generated output, and like we are trying to make it more flexible, create different styles to increase this success rate, because we can accommodate for different styles that people are more comfortable with.
Thank you.
But it merge request acceptance.
Hi. I will use this opportunity to ask two questions. One is about the quality of the documentation. So my question is, how much is stating the obvious from the code, and how much does it provide the very useful information, right? So kind of...
It does state the obvious a lot, but this is not necessarily a problem. Because what is obvious for you, it might not be for someone who's just onboarding in the team and trying to understand the code base. So, like, what is obvious is not. It really depends on your experience in the code base. So, again, you get different feedback from people. Say, hey, this is obvious, and some people say it's not obvious. But there's another advantage that even though like there is some redundancy that you could just clearly see reading the lines, is that there are situations that it might be useful for you to send data to the LLM, and instead of send the whole code base, you can just send the documentation. And the obvious part are there, but it's going to be very precious to save context size. Instead of sending the whole code base, you just send a very nice documentation and a signature of the function. And you can have, like, for example, in the flow that we are creating right now, the high-level documentation based on that. That's exactly what we want to do. Documentation, the signature, and we are not sending code, and it will be able to understand because the documentation has this kind of redundancy. So it might be redundant for the humans, but also might be useful for the AI.
And second question will be, do you measure coverage of a unit test only, or do you measure like of API test, integration test, the more complex ones?
Actually, I'm not entirely sure. We use Jacoco for Android. In iOS is still in progress, just the test part. So we're still like finishing up. But I believe that is just unit tests that we generate. We calculate the coverage. We know for sure that for the tool itself is just a unit test. But I'm not sure if like on the engineering portal, like code coverage, if it's just unit tests. It's aggregate, right? So it's aggregate, yeah.
It also includes UI tests,
Yeah.
as far as I know.
There you go.
Hey, I'm from Kayak, so this might be a pretty basic question for all the people from Booking, but you've showcased developer experience index on 2 of your slides. I was wondering if you could explain a bit more how you get to those topics and how you gather the data.
Yeah, it's a third-party tool. So it's called, I think, I don't know the name of the company, but it's the URL is getDX, get D and X. And it calculates this, it has the whole like structure on how it calculates. And the good thing is benchmark against the industry. So if they have data about other companies, and you can see that how well you're doing compared to 75 percentile or 95 percentile of the industry. So it's pretty cool. And that's what we, at the company, we're using to calculate developer experience. So it's not done by us.
Awesome, thank you. And perhaps I have a second question. You mentioned that when you're generating tests, it also creates a merge request. How do you handle human interactions with the generated merge request? Do you actually have engineers go in and change the merge request by themselves? Or do you have another set of prompting where you also guide the generated tests?
So right now we support 2 types of interaction. One in which you can locally generate the MR, and before even raising the MR, the engineer can actually edit the code and then submit an MR. That is how you do it with the tool, but locally. And second flow is from the UI. So we have a web UI using which you can select the folder and the files for which you want to generate, and there you'll get a generated MR in the end. So again, you can check out the branch on your local and add more changes to the MR, and in the review again, other people will interact and make some changes. So that's how the flows right now work.
What I usually do is, if I'm not looking at any type of other type of work, I run locally, and I see what's going to happen. But if I'm build something else and I want to run in parallel, I run on CI, because that frees up the resources of my computer to do something else, right? So usually that's what I do. But as she said, like if you go for CI, it will automatically create the branch and push. Locally, it will just change the files, and you decide what to do with it.
Hi, thank you for the talk. I have a small question. Like, if I use AppGenKit to generate my documentation, but I decide to add some more information, like maybe there's something in forward experiment or something. The next time the update is gonna run, is it gonna wipe out the extra information I added, or is it gonna put it in the context and save it somewhere?
Yeah. So if you look at the documentation generated by our tool, in the end, there is an ID that we add. And based on this ID, when you run the update thing, it identifies this was generated by our tool. So that ID is really important. If you wipe that out, maybe it will not touch it at all. But if you just keep it, it will add on to what was there existing, including what it was before and your changes. Does that answer?
And the second question is about the update part. Like, why don't we just automate it? Like, why is it had to be you developer driven? Is it automated, the update one?
The only reason we don't do this is because everything that goes into our code base, we want it revealed.
Okay.
So it could definitely be automated that would automatically do it. But in the end, someone needs to review, and we don't want to flood developers with merge requests every day. I could document the whole code base in 1 hour or so, right? But the bottleneck is people reviewing it, and we don't want to overwhelm them. We want to minimize the effort, so we allow them on their free time to do the task, basically.
Yeah, but the idea is to improve the developer experience, right? So if they have to keep in their mind that if they're refactoring or they make some changes in the API, then it's on them to keep updating the AutoGen kit. Like, then it's perhaps like an added effort, right?
It should be very trivial for us to automate that. It's just a matter of the community wanting it or not. So it's more about that. Like it would be even easy. I have confidence that at least for documentation, we don't even need code review because it's on a level that I believe it's good enough, and it doesn't affect production. But we still want to have humans making sure that we have at least one guardrail made by human. So that's the only reason.
And the one last question.
Thank you. Half of my question was already asked there, but to continue on that, why do you only choose to update documentation that was already written by the AutoGen kit, not just, documentation I write, because it's text after all?
Basically, we don't want to be intrusive to the developers. So if they manually documented something, maybe there has some information that are very hard to infer from the code base that's only in the head of the developer. So we don't want to override that. The developer has an option. If they want to have this documentation automatically updated, they could just delete the documentation and let us manage it, right? So it's out of respect of the information that we believe it's there on the manual documentation that we don't want to touch it.
And to follow up, the up-to-dateness of the documentation is, I think, also quite important. And then one of the reasons I think right now people are writing documentation and also using this tool is because there's a score, like a maturity score to have documentation, right? I feel like, have you considered perhaps also a score that rates the correctness of the documentation? So then that's also an incentive?
Yeah, that's a good idea. I think at Booking, the technical writers were using a tool that calculates the quality as well. We plan to introduce that, but we didn't have the time to do it. But it's definitely a great idea. And instead of also looking for the quantitative data, also look for the qualitative data. Yeah. If there's anyone interested on this topic and want to help us add the qualitative part, I would love to get some support.
And let's do the last question before wrap up for the lunch.
Hi. I see that you mentioned that we tripled the documentation in the last 6 months, which is pretty cool. I was wondering if there's a push to index this documentation somewhere so that it's easier for developers to talk to a chatbot and figure out. And the reason that I'm asking this is that I see there's a lot of duplication of code in the guest app. And maybe we can reduce that if people know what's the preferred way of doing something in the guest app.
Yes. There is a working group at Booking called Dev++, right? That is looking into documentation for the whole company in a holistic way. And they were looking to ways to render the information there. But it's not just documentation, code documentation, which is what we're working right now, but it's also high level. For now, as far as I understand, Confluence is the way to go. But we are having some discussions to figure out, like, okay, but what about the code documentation? How we best display, how we best present to to the end user. So there's a conversation ongoing, but we still haven't come up with some final approach. But from our perspective, we are concerned first as generating the content, because the displaying part should be easy in theory. Like we just host it somewhere, render like Markdown, and put everything together in a single place, right? So for us, the content is the key right now.
Cool.
Keep in mind that it's a 6 months flow, so there's still a lot that we need to do.
Cool. Thank you, Purvi. Thank you, Paula. Let's do another round of applause for awesome talk. And now we have